Hi, I'm Matt, lead developer on IDPicker. In this tutorial, I'm going to introduce IDPicker 3's gene-centric features. First, I'll mention a caveat. IDPicker currently only supports mapping of human RefSeq protein accessions to HGNC gene accessions. Support for other species and databases will come later. When you first open up an IDPDB, if it hasn't had gene mapping done on it, you will get a prompt to do the mapping. If there has been an update to the mappings on the IDPicker server, it will first ask you if you want to download the new version. Then the protein accessions are mapped to the gene IDs. It happens very fast, so try not to blink. Afterward, the IDPDB will continue loading and may apply filters if they still need to be applied. Several new features are available after you have mapped proteins to gene. First one, the protein view has new columns for gene ID, gene name, chromosome, and gene family. The second, there are new tree grouping options in the protein view, by gene and by gene group. Gene groups are the gene-centric equivalent of protein groups. A gene group is the set of genes that match to exactly the same set of peptides. When tree grouping by gene or gene group, the pivot options still work as expected. The protein rows are grouped by either genes or gene groups. Note that a protein group can consist of multiple genes, and a gene can have multiple protein groups. I'll show a couple examples of that. This calmodulin protein group is an example of a single protein group mapping to multiple genes. This occurs when there is not enough peptide evidence to distinguish between homologous genes. These plectin protein groups are an example of a single gene mapping to multiple protein groups. This occurs when there is enough peptide evidence to distinguish between protein isoforms. The third new feature, you can do basic filtering at the gene level. Instead of minimum spectra per protein and minimum peptides per protein, filters will be applied as minimum spectra per gene, minimum peptides per gene, and so on. You may be wondering what happens to the proteins that don't have a gene mapping. They are given a gene ID prefixed by unmapped, so each unmapped protein gets treated as its own gene. Unmapped proteins happen for several reasons. It may be a predicted protein, indicated by XP instead of NP in the RefSeq protein accession. It may be a protein in your database that has been removed from the RefSeq to HGNC mapping database. Or it may be a new protein that doesn't have a mapping yet. Right now, that's all there is to it for gene-level data inside IDPicker. Check out the NetGestalt tutorial to understand how gene mappings allow easy export of IDPicker reports to NetGestalt.